welcome to my channel. In this video we are going to learn about how to prove that the given numbers are irrational numbers from 10th class real numbers first chapter. For example number 1, show that root 2 is an irrational. Let us assume on contrary root 2 be a rational number. Rational number in the form of p by q. But here I would like to express as a and b instead of p comma q. That's why root 2 is equals to a by b. The conditions for a and b are b not equal 0, a comma b are integers and co-primes. By cross multiplication we get a is equals to root 2b. Squaring on both sides we get here a square is equals to 2b square. On transforming 2 to left side we get a square by 2 is equals to b square. It means a square completes divide by 2. The quotient is b square. So 2 divides a square, then 2 also be divides a by previous theorem. A is divided by 2, then 2 is a factor of a. It is equation number 1. Now in equation number 1, 2 is a factor of a. It means 2 is complete divides a. So that's why a is can express as a is equals to 2c. C is some integer. It means a quotient part. So again squaring on both sides we get a square is equals to 2c whole square. But a square is equals to, we can express as a square as 2b square. Already in previous step we have a square is equals to 2b square. That's right, 2b square is equals to 4c square. By simplifying, b square is equals to 2c square. On transforming 2 to left side we get b square by 2 is equals to c square. It means b square completely divided by 2, quotient as c square. It means 2 divides b square, then 2 divides also b. So if 2 divides b, 2 is a factor of b. It is equation number 2. From equation number 1 and 2, 2 is a factor of a and b. According to our assumption, a comma b are co-primes. But by equation number 1 and 2, 2 is a common factor for both a and b. This is contradict to our assumption. So our assumption is wrong. Therefore 2 is not a rational number. It means if a number not a rational, it will be an irrational number. That's why here we get root 2 is not a rational. It means root 2 is an irrational number. Hence proved. Example number 2. Prove that 6 plus root 2 is an irrational number. Here on contradict we let us assume on contrary that 6 plus root 2 is a rational number. Rational number b in the form of p by q. So instead of p comma q, here I would like to express as a and b. Here 6 plus root 2 is equals to a by b. The conditions for a and b are b not equal to 0, a comma b are integers and co-primes. Now by transforming 6 to right side, we get a root 2 is equals to a by b minus 6. By simplifying, we get root 2 is equals to a minus 6b by b. Here, since a comma b are integers in the amount of right side, a minus 6b by b a rational number, and also root 2 also be a rational. Why? Because a minus 6b by b is equals to root 2. It means if a minus 6b by b is a rational, then root 2 will be rational. But this is contradict the fact that root 2 is an irrational. So our assumption is wrong. So therefore 6 plus root 2 is an irrational. And proved. Another example, prove that 6 plus 3 root 2 is an irrational number. Let us assume on contrary 6 plus 3 root 2 is a rational number. 6 plus 3 root 2 is equals to a by b, b not equal to 0, a comma b are integers and co-primes. On transforming 6 to right side, we get a 3 root 2 is equals to a by b minus 6. By simplifying, we get a 3 root 2 is equals to a minus 6b by b, and root 2 is equals to a minus 6b by 3b. Since a comma b are integers, then the amount of right side here a minus 6b by 3b is a rational number. Then root 2 will be also rational. But this is contradict the fact that root 2 is an irrational number. So our assumption is wrong. Therefore 6 plus 3 root 2 is an irrational number. And proved. Another example, prove that 5 minus root 3 is an irrational number. These questions are only model questions. Now here, by improving, let us assume on contrary same 5 minus root 3 is a rational. So 5 minus root 3 is equals to a by b, b not equal to 0, a comma b are integers and co-primes. Now minus root 3 is equals to a by b minus 5 on transforming 5 to right side. Now by simplifying, minus root 3 is equals to a minus 5b by b. By multiplying minus on both sides, we get a root 3 is equals to 5b minus a by b. Since a comma b are integers, then 5b minus a by b a rational number, and root 3 also be a rational. But this is a contradict the fact that root 3 is an irrational number. So our assumption is wrong. Therefore 5 minus root 3 is an irrational number. And proved. Like this, it's a very, very important. Example number 5, prove that root 3 minus 5 is an irrational number. How to prove? Improving. Now here, let us assume on contrary root 3 minus 5 is a rational number. So root 3 minus 5 is equals to a by b. B not equal 0. A comma b are integers and co-primes. On transforming 5 to right side, we get a root 3 is equals to a by b plus 5. Now on simplifying, we get a root 3 is equals to a plus 5b by b. Since a comma b are integers, then 5 plus 5b by b is a rational number, and root 3 also be a rational. But this is a contradict fact that root 3 is an irrational number. So assumption is wrong. Therefore root 3 minus 5 is an irrational. Hence proved. Now one more example. It's very important for annual examination. Let us assume here in given question, what is given? Prove that root 3 plus root 5 is an irrational. In proving, let us assume on contrary, root 3 plus root 5 is a rational number. Rational number be in the form of p by q. But here I would like to express a and b instead of p comma q. So root 3 plus root 5 is equals to a by b. Conditions first. A and b not equal 0. A comma b are integers and co-primes. Squaring on both sides, we get a simple way. Squaring on both sides, we get here root 3 plus root 5 whole square is equals to a by b whole square. Now in amount of LHS is in the form of a plus b whole square. The expansion form of a plus b whole square is a square plus b square, a square plus b square plus 2ab plus 2ab. Now here a square is a root 3 square, b square is a root 5 square plus 2ab, 2 root 3 into root 5 is equals to a square by b square. Now root 3 whole square is 3 and root 5 whole square is 5. So 3 plus 5 plus 2 root 15 is equals to a square by b square. Now 8 plus 2 root 15 is equals to a square by b square. On transforming 8 to right side, we get a 2 root 15 is equals to a square by b square minus 8. By simplifying, we get a 2 root 15 is equals to a square minus 8b square by b square. Root 15 is equals to a square minus 8b square by 2b square. On the right side, we have only in terms of a and b. So since a comma b are integers, then a square minus 8b square by 2b square is a rational, and root 15 also be a rational. But this is contradict the fact that root 15 is an irrational number. So our assumption is wrong. Therefore root 3 plus root 5 is an irrational, hence proved. Now one more example. Root 7 minus root 2 is an irrational. Now let us assume on contrary same. Root 7 minus root 2 is a rational number. Rational number be in the form of p by q. But here I would like to express a comma b instead of p and q. That's fine. Root 7 minus root 2 is equals to a by b. Conditions first. A and b or b not equal to 0, a comma b are integers and coprimes. Root 7 minus root 2 is equals to a by b. On squaring both sides we get a root 7 minus root 2 whole square is equals to a by b whole square. In left side we have root 7 minus root 2 whole square. It is in the form of a minus b whole square. So the expansion form of a square minus b square is a minus b whole square is a square plus b square minus 2ab. Here a square is root 7 whole square plus root 2 whole square minus 2 root 7 into root 2 is equals to a square by b square. Root 7 square is a 7 and root 2 square is a 2 minus 2 root 14 is equals to a square by b square. Now we get a 9 minus 2 root 14 is equals to a square by b square. On transforming 9 to right side we get a minus 2 root 14 is equals to a square by b square minus 9. Now by simplifying we get a root 14 is equals to minus of a square minus 9b square by 2b square. Now here we have root 14 is equals to 9b square minus a square by 2b square. Since a comma b are integers, then 9b square minus a square by 2b square is a rational number and root 14 also be a rational. This is a contradict the fact that root 14 be an irrational number. So our assumption is wrong. So therefore root 7 minus root 2 is an irrational. Hence proved. Now one more example. Show that 1 by root 2 is a rational. Let us assume on contrary 1 by root 2 is a rational number. 1 by root 2 is equals to a by b, b not equals to a comma b are integers and coprimes. By cross multiplication we get a root 2 into a is equals to 1 into b. By simplifying we get a root 2 is equals to b by a. Since a comma b are integers, then b by a is a rational number and root 2 also be a rational. But this is a contradict the fact that root 2 is an irrational number. So assumption is wrong. Therefore 1 by root 2 is an irrational. And proved. Thank you for